and Assalamualaikum. Today we are going to present about Green's theorem. But before that, I would like to introduce my group members. We have Muhammad Akil Ahnaf, Ahmad Fatrun, Muhammad Ikhwan, Akmal Uman, and me, Ramona Shakira.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikhwan Hakimi bin Zulkarnain, and today I will talk about what is Green's theorem. Green's theorem briefs a relationship between the line integral of a two-dimensional vector field over a closed path in the plane and the double integral over the region it encloses are related by Green's theorem. Green's theorem is a specific example of the statement that the integral of a two-dimensional conservative field over a closed path equals zero. Green's theorem is a subset of Stokes' theorem, which is far more general. Green's theorem declaration that different types of integral are equal can be used to compute either. It is sometimes used to translate a line integral into a double integral, and it is sometimes used to transform a double integral into a line integral. As we can see in this picture, let C be a plane region bounded by a positively oriented piecewise smooth simple closed curve in a plane, and D be the region bounded by C. If f and g are xy function with continuous partial derivative defined on an open region containing D, then integral fxy dx plus gxy dy equal to double integral dg over dx minus df over dy multiplied with dA.
This is a basic example using Green's theorem. I will pass to Akmal Uman to present the solution.
Today I'll be presenting about the solution for the basic questions. The basic questions were presented by Ramona. So first of all, we need to check whether the questions met the requirement for the Green's theorem. As you can see here, the x unit limit is 0 to 1 and the y unit limit is 0 to 2x, so it is met the requirement because it is positively oriented. So next, as we all know, the general equation for Green's theorem is single integrate of p dx plus q dy equals to double integrate of partially derivative q to the x unit minus partially derivative of p to the y unit. So first of all, we need to find the p and q. So based on the questions, we will get p is 5xy and q is x cubed times y squared. So once we get the pq, we need to find the partially derivative of q and p. So for the q is only for the x unit, so we'll do the 3 here, we'll bring it to the front and then minus 1. So y will let it be because it is only to the x unit, so we'll get 3x square times y square. Same for the p, we will get 5x. So once we get the partially derivative of the q and p, we'll bring it to the equation. We'll get 3x squared times y squared minus 5x. Next, we'll bring in the limit for the x unit and y unit. So we'll get it like this. As you can see here, this is dy dx. So we'll need to integrate for dy first. Next, when we integrate for the y, and then we'll need to bring in the limit unit for y unit in dy. So we'll get 8x to the power of 5 minus 10x squared, limit of 1 to 0. So we'll do the same step as the y unit, so we'll get minus 2. So that's all from me. Thank you.
Example of Green's theorem question related to electrical application. In electrostatic, the electric field line cannot form any closed loop. However, in the electric field line in electrodynamic form closed loop, which is entirely based on Green's theorem, such as relation between integral and differential form of Maxwell equation and the energy of steady current. Therefore, by using Green's theorem, evaluate the following line integral. Integration of xy dx plus plus x square y cube dy, where C is triangle with vertices of 0, 0, 1, 0, and 1, 2, which is positively oriented. So, note from lecture note for this solution is integration of fxy dx plus gxy dy is equal to double integral dg over dx minus df over dy, close bracket dA. So the general equation of this solution is integration C f dot product r prime t is equal to double integral dg over dx minus df over dy, close bracket dA. So for the solution of this question is, we must know the value of dg over dx and df over dy. So fxy, we know that fxy is equal to xy and the gxy is equal to x square y cube. So we must know the value of dg and dx. So we must differentiate this equation in terms of y. So xy differentiate in terms of y, we will get x, and the gxy equal to x square y cube, we must integrate in terms of x. So we will get 2xy cube. This is the sketch from the info we will get from the question. This is 0, 0 and 1, 0 and 2, 2. We know that this line is equal to y equal to 2x. So for the range of y is 0 until 2x, because the equation of this line is equal to 2x, and the x is equal to 0 until 1. So we must substitute the value of dg over dx and df over dy. So we know that dg over dx is equal to 2xy cube, and the value of dy over df over dy is equal to minus x. So we must integrate this equation dy over dx, and the limit of x is 0 until 1, and the limit of y is 0 until 2x. So we must integrate this equation in terms of y first. So we will get xy power of 4 over 2 minus xy. So we must substitute 2x into y term. So we will get 8x power of 5 minus 2x power of 2 dx. After that, we must integrate this equation in terms of dx. So we will get 4 over 3 x power of 6 minus 2 over 3 x power of 3. So we must substitute value of 1 in the term of x. So we will get 2 over 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fatrul Nazim bin Sulaiman, and now I will talk about the conclusion for this topic. As you can see, this is the Green Theorem's formula, and in this conclusion, utilizing this method will make assessing the line integral of a smooth vector field around a basic closed curve much easier for pupils. By integrating over the perimeter, the Green's theorem may also be used to compute the area and centroid of flat figures. That's all from me.